So first, their acceleration is the derivative of velocity there, which is just 2. The particle that is at rest, that would be when the velocity is 0, so that's 3 half seconds there. 3, the keyword here is speed. So speed is always a positive number, so just make sure you take the absolute value of the velocity. So v of 0, take the absolute value of that, because if you put -3, that would be wrong. The speed has to be a positive value, so it's positive 3 centimeters per second. Make sure the acceleration, you got the centimeters per second squared as well. And then 4, when you take the interval there, we end up plugging in the initial condition, x of 2 equals 3, so we get c equals 5, and then our x of t is t squared minus kt plus 5. Did you guys, we didn't get to check your answers from yesterday, the previous assignment, so if you want to look at those, I think you had to finish off that one section. So you had to do whatever number it was up to 22. So I'm going to check your answers for that. And then we'll start on the next section. Let's start with 16. And any questions yet on that? Were there any of them that you guys remember struggling with?
So how I got
I figured out exactly how you got your answer, but then I couldn't figure out how Daniel got his answer because I remember asking him.
Let me pull it up here. Ball is dropping your bridge. That's going to be it, yeah. Because if you're at height 0 and you drop it down, then the height would be at -1.
That's definitely what I forgot. That's what I forgot too.
Daniel's got a lot of experience with physics problems, so.
Yeah, that's what I was saying.
Yeah, they hurt my brain.
It was actually kind of simple the way you're supposed to do it, but
Yeah. All right. The hardest one in this section definitely was the one we did together, which was 22 there.
Oh yeah, if you give that one
This-
some homework, it's
Yeah.
blank when I walk in.
Yeah, that one is kind of crazy. Sometimes I don't know what these are like when I start them. So. This is the first year I've used this text. So. All right, all the other ones are good though. So before we start in the next section, it's very short. It's just more integration, but I have a little challenge for you to do. At the end of these problems, on number 28, you're asked to find each of these derivatives without looking them up. And as a note, it is very important that you know each of these without referring to notes. So take a minute and go ahead and write what you think the answers for all of these: trig, e's, natural logs, base exponential, and log functions are. Take a second. And that's number 28. You can see them all written there. Take a second so you can do all those. So we're going to be doing the inverse of those, the integral of those today. you know them, you should have done that. If you know it all, fine. So, all right, derivative of e to the x is e to the x. Derivative of natural log of x is 1 over x. Derivative of sine is cosine. Derivative of cosine is minus sine. Derivative of tangent is secant squared. Derivative of cotangent is, do you know that one? Do you know it?
Probably not.
Should be able to mostly run through this top one. So where the top one's pretty easy.
Top one's fine.
Yeah.
The other ones, not so much.
Nobody knows cotangent?
I wrote something down.
Minus cosecant squared.
I literally had everything but this.
Derivative of secant, you know that one? Yep. Makes sense. Cosecant. So remember these sort of patterns. Sine and cosine are kind of a pair, right? Tangent and cotangent behave similarly. Tangent is secant squared. Cotangent is minus cosecant squared. Right? Same with secant and cosecant. They're kind of a pair, in that they both have this double trig function here, right? So secant is secant x tan x. Cosecant is minus cosecant x cotangent x. Same idea, except an opposite sign. And always one of them is negative as well, right? So
Whichever one starts with the C is negative.
right. Equal
That's
that
all I
out.
think I did right there.
So they all have these pairs that work out here. All right. The base exponential function there. It isn't really a to the x ln of a. I'm going to see it for a minute as well. A to the logarithm. That one's probably the most one that you wouldn't know. Over x ln of a. So I wouldn't fault you if you didn't know log is a long one. But the other ones you should know, you need to know those.
Yeah, I need to learn those. I also need to learn polyatomic ions for chemistry. I got a lot of things I need to learn.
So you do kind of learn these though they drill in more as you go because you use them throughout the year. So they do get drilled in. And we're going to be doing the opposite. We're going to integrate these today. So if you're going to integrate, well, you got to know the derivative. So that's the point of this. Just make sure you know that. The next section is super small. You guys probably could have even done this on your own yesterday. It's just giving you some integrals and their answer. Okay? So it's just a table of some integrals. It's just the exponentials and trig functions. These are not things that you should really memorize or anything. The only one here that would be difficult if you don't know the derivative is this one. And honestly, I don't know if you'll ever see that. The integral of a to the x is a to the x times 1 over the natural log of a. It's basically the opposite of what we did here, because it's 1 over that essentially. Right? So that's the only thing that's really hard. And you don't even see the integral of the logarithm here. So this is kind of rare that you would see this, like I said. The main things that you need to know are all of the trig functions, figure out how to work backwards for these, and then e to the x. And these are all simple ones in that they don't have anything like plugged into them. So there's no e to the 3x squared or something like that. The reason why is because you need a different sort of technique. It's called a U substitution, which we'll do next, in order to do something like the integral of e to the 3x. It's not quite as easy because, well, you got to kind of think of it first, because the derivative of e to the 3x is 3e to the 3x, right? Because the e to the u, whatever, times the derivative of that. So you got to think sort of in reverse. So right now, all of these are just like the parent function, just e to the x or the sine of x, whatever. And so again, I wouldn't worry too much about this one, especially if you need to look it up as we're going it, because I mean I don't know that I would use it enough to even know that one right off the top of my head. I'd figure it out, but it's not something that I would have to memorize off the top of my head. Really isn't that much. But all of these, let's just take a look at some and see if you can remember them here. It gives you this chart to help you remember the signs. I don't really find this that helpful, but I think it's just a little bit more confusing. Um, I can just remember the derivative of sine is cosine, the derivative of cosine is minus sine, so you just have to think of the verbs. But here's a little chart. Again, I don't really think it's helpful, but if that helps you in some way. Okay, so let's go ahead and just look at these few examples. There isn't really anything to explain other than try to think in reverse or derivatives. All right, so the first one, remember numbers we can sort of pull out in front, right? The only thing being here is, so derivative of sine is cosine. Derivative of, what you want to think is like, basically, I would leave the negative in there. Although you can pull it out, I would kind of think of it like this, when we're just ignoring the 3. But I would leave the negative there, because there's the question you want to ask. You want to think, what function do I take the derivative of and then get a negative sign? It's obviously cosine, right? Cosine is minus sine. So by leaving that negative in there, it's even more clear that it's just regular cosine, right? Because regular cosine gives you minus sine. So then this is just 3 cosine of x plus c. That's it. And then it's a good idea to just kind of run it in your head backwards. Take the derivative of this, just think in your head, derivative of cosine is minus sine, so minus 3 sine, that works. All right, so that's the first one. Number 2 here. Now, if you need to refer to this chart, you can, but just like the derivative of e to the x is e to the x, the integral of e to the x is e to the x as well. And as we learned, like these integral properties, you can basically just view them as separate integrals. So really what we're doing, you don't need to write this, but we're actually doing the integral of e to the x minus the integral of 2 to the x to the x. That's essentially what we're doing. We're not writing that, but that's essentially what we're doing. So then we've got e to the x, and then you might need to look up here. It's the one that's the inverse, so it's going to be minus 2 to the x over the natural log of 2. M plus c. And let's just kind of run this backwards again. E to the x, so let's just go ahead and take the derivative. If we take the derivative of this, it should equal this, right? The derivative of e to the x is e to the x. The derivative of this would be, this is just a constant. Remember, anytime you have a natural log of just a number, it's just a constant. So it's basically minus 1 over natural log of 2. The derivative of this is 2 to the x times ln of 2. So then this cancels with this and leaves us just 2 to the x. So that's why it works out. And that's what we do. All right, number 3. This one you're going to want to write probably as a rational exponent to start. So this is 5 t to the 2/3. And you guys practiced that a lot yesterday, so hopefully you got good experience with that. Add and then divide. So when we add there, it becomes 5/3. So it becomes 5 t to the 5/3. Now it's going to be divided by 5/3, which means we flip and multiply, right? You want to write it like this, man. We're going to end up flipping it and multiplying. And then what happens when you flip and multiply this? 5 should just cancel out, right? This would now be on the bottom, this would be up here. So this would actually just be 3t to the 5/3. And then the next term So we have to think what, when we take the derivative, gives us cosine. Just sine, right? Cosine. So plus 3 sine of t minus 1, so it's going to be minus t plus c. Especially with the trig functions, I like to just take those derivatives and just make sure it works. So if I were just to single out this part, 3 sine x sine of t, derivative of sine is cosine, so 3 cosine t. Just to make sure the signs match up. But it's really not too well. Okay, and then number 4, integral of secant y tan y. Your first instinct might be like, well, how am I going to do like an integral of a product with like a quotient, right? But then you remember, oh, there's a function when I take the derivative, it's secant x tan x, right? Yeah. So that's going to be our little shortcut there. Even though it seems kind of hard, we've got this here, which tells us that the derivative of secant is secant x tan x. So this is just going to be secant of y. You can also view this as like pulling the 1/4 out. So it's important that you know the derivatives so that you can then think backwards. All right, and then we've got just one with an initial condition here. Just a little good review of some trig values in the unit circle. So it says if f prime of x is the cosecant of x quantity squared, and f of 5 over 4 is 3, find f of x. So we need to do an integral to get from f prime to f. The way that this is written is kind of intentionally to throw you off. But you think, well, yeah, I don't know how to do an integral of like power rule or something, right? But just remember that this is the same thing as writing it as cosecant squared x. It's the same thing. Just again written that way, I can throw you off. The x there. Okay, so what function connects with this cosecant squared? Right, yeah. That's what you want to think. What function gives me this as a derivative? Well, cotangent gives you minus cosecant squared, right? So in order to get a positive, then I want it, my f of x to be minus cotangent squared, or sorry, cotangent x. Let's see. And then we'll plug in our initial condition there. So f 5 over 4. It's a negative cotangent of 5 over 4 plus c equals 3. Now we need to think back to some unit circle values here. Cotangent of 5 pi over 4. What's that? Can we just draw a little circle real quick? And then just think about where 5 pi over 4 is. So it's one more of the fourth than whole pi, right? So it's going to be down in this right here. So in this quadrant, both the x and the y's are negative. Anytime we're at a fourth, though, remember the coordinate pairs of the fourths are always the radical 2 over 2's. This is a negative radical 2 over 2, comma negative radical 2 over 2. A cotangent is the x over the y. Remember that as well. Just remember how to do all that stuff. Because so cosine, just a little refresher, cosine equals the x, sine equals the y, right?
Oh yeah, okay.
So tangent is sine over cosine, so it's y over x. Cotangent is x over y. So it's the x over the y. In this case, it wouldn't matter if you have them switched. It's a negative radical 2 over 2 over negative radical 2 over 2, which is just 1. So this ends up being negative 1 because we got that negative out there in front. plus e is 3. We then can add the 1 over to get c is 4. And then so x minus cotangent x. So most of the rest then is just practice. Let's do a couple of these harder ones. What's one or two that looks really challenging? What do I do? Like pick out 2 of these. What do you guys want to do? Well, they're all easy.
They all look bad.
I don't know, man.
Yeah. Yeah.
Yeah, I agree with that.
Okay. That's awesome.
First time ever.
Alright. Well, let's look at number 12 first. Okay. So yeah, this looks kind of challenging, but I think after you see it, you basically all these that look hard, you want to simplify them first. So these are the same base, which means you can subtract the exponents. So it's just 5 to the 3x minus 2x dx. This one just becomes the integral of 5 dx. So then it's pretty easy. It's just like a base exponential. And then you can just do that part real quick just so you can memorize how to do those. Number 9, you also have to simplify, but it's not quite as apparent. So what's a good one? Anytime you see this fraction with like an adding or subtracting, so like number 9 and number 6, you're going to want to split this into 2 different signs. So we're going to want to write this as 3 over the cosine squared of x plus the cosine squared of x over the cosine squared of x. So just split them with the same denominator. Anytime you see that, it's generally going to be the way you want to attack that. So the second half of that is pretty obvious. That just becomes 1, right? So that makes it easy for us. The first part, though, is still a little bit unsure because if you're going to try to integrate something, there's nothing that you take the derivative of that's going to give you a cosine squared, right? Is there any of the derivatives that give you a cosine squared? No. And these are designed so that they work with everything you know. Do they have an idea? Okay, it's super helpful to think of it that way. Give it. Well, one more thing we can do even better, because we don't have a thing that we can differentiate and that gives us that, right? Because everything that we need here, we need to think, oh, something might differentiate it, we'll give me that. What function do you take a derivative of that gives you one of the cosine? There is that one, right? Mm-hmm. So we still need to do something different. Close, secant squared, yeah. So this is the same thing as integral of 3 secant squared. It's pretty tricky, right? Because secant is 1 over cosine.
I never would have guessed that.
And this, yeah, it's kind of deceptive. Because this would be the same thing as this. That's equivalent because 1 squared is 1, so you could write it like that, which would be the same thing this is. And then we can do that because the derivative of tangent is secant squared, right? So this becomes 3 tan x plus x. Which you would never get from just taking the derivative of this. You would never write it like that. But unless it's, yeah. Let's just run through and see if there's, so like 1 should be fine, 2 should be fine, 3 is fine. Okay, so 4, same idea here. Number 4. So you're gonna want to rewrite that. 5. How are you gonna rewrite this? 2 over e to the negative x. Yeah. This one you're gonna split this obviously, right? And then the x will cancel here. And you'll just have the 1 over there. That will be easy. The fraction will go away when you split it. This one's already fine. This one's fine. Just write x to the negative 4. I did that one. How about, let's look at 10. Let's see if you guys can figure out, maybe you can figure this one out now. How do we want to rewrite this? Maybe it's not as obvious. Okay, so that's kind of what I was thinking at first. So let's do a little experiment here. This is just going to be some just doodling, try to figure out what works, right? So if we do it like that, then we end up with, let's just forget the integral stuff now. 1 over sine squared over cosine, right? And then so we would probably want to flip it so we don't have this double fraction. So is that helping us at all? Okay, so what about if we write it a little bit differently? What about if we write it as cosine times 1 over sine squared? I'll just write that way instead. So this, so what would it be if we wrote it that way?
Secant squared.
Right. Right. So this still doesn't quite work though, right? But this is the idea, because we don't have something that's going to quite work like this, right? But we can see kind of the right idea here. Okay. So don't write this yet. Is we want to write it as some product where we end up getting this as like an answer to the derivative. Okay. So we go down this path. It almost works, but not quite work. Right? Almost gets this there. Okay. So let's take a quick step back. This is again the right idea, but back here. Because I would think the same thing here. So instead of like replacing that with sines and cosines, which you generally want to do, what about from the outside if we just write it as like 1 over sine x times basically 1 over tan x? Does that make sense to split it that way?
Makes sense. I thought about that, but I couldn't figure out what it was.
Right. Yeah. No. But don't worry about it if you couldn't come up with that on your own. But not all of them are going to be like you automatically see what to do right off the outset. You might have to experiment a little bit with manipulating fractions. So then 1 over sine is the same as cosecant, right? 1 over tangent is the same as cotangent. And that is something we have minus cosecant cotangent, right? 1 over cosecant minus cosecant cotangent. So then this is minus cosecant x.
You don't know that your trade pretty well to
Yeah.
do that problem.
Yeah. Yeah. Trig is definitely real important. I bet you guys could figure out how to. You can figure out how to rewrite number 11. It's actually not bad. So remember, when you take the square root, if they're multiplied, you're allowed to split that up. You can think of this as the same thing as just square root of 9 and the square root of e to the 2x. And then square root of 9 obviously is 3. This, if you think of just a rational exponent, the top is the power which we have there, just e to the 2x divided by 2, because that's what we think x up here is 2. So then it's just x. I think that does it for the hard ones. Let's take a look at. Alright, so we got some equation of tangent lines. I don't have any of these in the notes. Alright. Okay, let's try maybe one of these, one or two of these equation of tangent lines. And let's back to derivatives. Let's try number 14. Yes, I think can do number 13 on your own. That's on a different page for you guys. Number 14, wouldn't hurt to get a little extra practice with these trig functions. So how do we write an equation of a tangent line? Do you remember that? The derivative at the point, right? So 14, we need to do derivative, not an integral. So this is where, like in the AP test, all of these are mixed together. So there's no like, this is integral section. Get in your integral mindset. Here's derivative section.
Really go
So you're gonna go back and forth. So this is derivative, right? We're talking about the slope now. So we need to get an m, which is the derivative of this. Right. So the derivative of cosine is minus sine, right? We already have a negative there though, so it just can become positive sine of 2x, and then you have to do times the derivative of the inside, right? So it'd be times 2. So I'm just gonna write the 2 in front there. So 2 sine of 2x. But that's our slope. and we want to do it at this point, pi over 6 times negative a half. So that's going to be our x value. So we want to do 2 sine of 2 times pi over 6. Our slope. So that's going to be 2 sine of pi over 3. So what's the sine is y, right? What's the y coordinate at pi over 3? So radical 3 over 2.
You have something wrong. Or you can
Right.
the wrong one too.
Well, you have pi over 6. Maybe that's confusing. Pi
Yeah,
over
that's
6.
what I did.
Because pi over 3 is going to be up there, right? So the x is going to be the half and the y is going to be the radical 3 over 2. So 2 times radical 3 over 2. The 2's cancel. So our slope is radical 3. It really does help to draw a little circle. I know it might seem like kind of tedious for a while, but even though I've taught for a while, like it still helps me to just visualize it. Especially if you're a visual learner anyway. Just draw a little circle and put a dot where it goes. And then you can also see visually the x is smaller than the y. All right, so we got a slope. We already got a point, right? So now we do our y minus y1 equals m times x minus x1. So y minus negative a half, so it becomes y plus a half. Equals our m, our 3, equals x minus 6. Things don't really jive together very well on that one, so that's probably okay. Just like this. Nothing really multiplies for me. So what I would like for you to do tonight is up through 13, and then also we need to try number. Do you guys want to do 15 or 16?
Whichever one is most painful, don't let me.
All right, Preston. Okay.
Alright, you put it on B,
I don't know which one to say.
16, because I
Alright.
like that easier.
Yeah, I think 16 is
All right. So we need to do. We've done several of them, but 1 to 13 and then number 16.
Usually longer than
26. So you got like a minute and a half still. But
Yeah.
those questions take a little bit of time. So.
Kristen, did you see that the master posted the review already? As if I've even done the notes. I haven't even done the notes yet.
I was pretty well.
There's only like 5 slides, so I'm just looking at it right now. But I haven't even done that yet.